Bam, Mr. True. Let's do two more examples of verifying identities. Okay, so we have 1 over 1 minus sine theta plus 1 over 1 plus sine theta equals to secant theta. Don't forget, we want to simplify, and clearly the left-hand side of this identity is much more complicated than the right. So let's see what we can do. We have two terms. Over here we only have one. So there's a place to start. So I'm going to take this and multiply the first fraction by 1 plus sine theta on the top and bottom. And on the second term, or the second fraction, we'll do the exact same thing, only except it's going to be 1 minus sine theta. Didn't leave myself very much room to write here. So what do we have? Now I'm going to write this as one big fraction because I'm setting up my common denominator as I go. So we're going to have 1 plus sine theta plus, now I'm going to use parentheses on the second top, not because it's really going to matter with this particular question because it's plus and the parentheses really aren't going to do anything. But if it were minus, that would have to get distributed through the parentheses because there's more than one term in this second fraction. And if you did not do that, you would have sign errors and your proof would fall apart. So 1 times 1 minus sine theta is just 1 minus sine theta. And the denominator is going to be, now a lot of times I will leave these in factored form because a lot of times stuff cancels out. But I can look at the top already and see it's going to be sine minus sine. So my numerator is only going to be a value of 2 and there's no chance of anything canceling with the denominator. So I'm going to go ahead and multiply this out. Now again, we do have the same denominator twice. So we got 1 times 1 is 1. And then 1 times positive sign is, well, plus sign. And then 1 times negative sign is negative sign. Well, when you have a positive sign and a negative sign, they're going to cancel out. So, and this is a difference of squares pattern that you might recognize from Algebra 1. So the middle term is going to cancel out. Anyway, let me get back to what I was saying. 1 times 1 is 1. 1 times sign is positive sign. 1 times negative sign is negative sign. Those are going to cancel out. And negative sign times positive sign is negative sine squared theta. Okay, well, sine minus sine, those are going to cancel out. And I'm left with 1 plus 1, which is 2, which is really good because that's what I need. That's what I need over here is a 2. 2 times something. Well, oh, forgot my exponent of 2. Okay, now I've got 1 minus sine squared theta, and that does not look like this over here. So what can I do? Well, I'm out of space, so I could just stop and start working with the other side. And I think I'm going to go ahead and do that. But you might also recognize that, if you want to continue this with one side, secant is 1 over cosine, right? And 1 minus sine, actually let me go ahead and just keep working with this. Secant is 1 over cosine, so secant squared is equal to 1 over cosine squared. So I need a denominator that has a cosine function in it. Well, the first Pythagorean identity that says sine squared plus cosine squared equals 1, if I wrote one side, if I were to manipulate that, so one side of it said 1 minus sine squared theta, the other side would say cosine squared theta. So 1 minus sine squared theta is going to come out, and with a substitution using the Pythagorean identity, I get 2 over cosine squared theta. And we're just about done. 1 over cosine, well this is a 2, but if I bring the cosine squared function up, or if I remember that 1 over cosine equals secant, then I can bring the cosine squared function up and write 2 times the secant squared theta, and bam! I'm done. Alright, so please, if you got a full sheet of paper, do your proofs so that you keep the left and right hand side going down in columns. This horizontal work like this is not good when you have a full sheet of paper and you'd like to make it a little bit easier on your math teacher to grade. Alright, so 2 secant squared does equal 2 secant squared. We have this proof done, or this identity verified. Alright, one more example and I'm going to move on to the next video, which is going to be half angle, or excuse me, no, sum and difference identities for sine, cosine, and tangent. But first, one more example. So we have sine theta plus cosine theta over cosine theta minus sine theta minus cosine theta over sine theta equals secant theta cosecant theta. Okay, so we're going to clearly again work with the left-hand side because it's obviously much more complicated than the right. Well, we have two terms, and over here we only have one term, which means that I'm going to think that we're going to go ahead and find common denominators again and try and bring those fractions together and see what happens. Well, sine and cosine don't have anything in common, so I'm going to multiply this fraction on top and bottom by sine. Wrap that top numerator up in parentheses because we are going to have to distribute. There's two terms up there. Cosine comes over to this fraction, again, with parentheses, top and bottom, by cosine theta. And what do we get? Well, we're going to distribute. So we have sine times sine is sine squared. Sine times cosine is plus sine theta cosine theta. Now look, minus in the middle, and the second fraction has two terms. If you do not properly use your parentheses, you are not going to carry that negative sign through and your proof is going to fall apart. Make sure that you use your parentheses judiciously, a lot, to make sure you don't make any sign errors. Cosine times sine again, which is going to be sine theta cosine theta. And then cosine times negative cosine is negative cosine squared theta. And all of that is over my common denominator that I've set up, which is sine cosine. And I'm just going to write one big fraction because I've set up my common denominator. So sine theta cosine theta. Now, see that minus sign was what was originally between the two fractions, and that minus sign has to get distributed through the parentheses. And when you do that, what's going to happen? Well, we're going to get sine cosine, which is positive, and negative sine cosine. So those are going to cancel out. And we have a negative times a negative, which is positive. So our next line is going to be sine squared theta. Negative times negative is positive, so plus cosine squared theta over sine theta cosine theta. Now, we're really close to the answer. What is sine squared plus cosine squared? Go look at your formula sheet, or, if it's to memory, Pythagorean identity. That is equal to 1. And 1 over sine theta cosine theta. And my winter holiday decorations are getting in the way here. What's 1 over sine? Cosecant. What's 1 over cosine? That's right, it's secant. So we get secant of theta from 1 over cosine, and cosecant of theta, that looks like an E, cosecant of theta from 1 over sine. And boom, there we go, we are done. 2 more examples out of the way. I'm Mr. Taru. Go do your homework. Woo!